Alright, we're going to step it up. We're going to do some modeling and solving with two-step equations now. And you'll see there's just two steps to kind of finding the answer, getting x by itself in each one of these questions. That's our goal, right, is always to find x. First up, we need to ask ourselves, like, what is being modeled here? What is being shown here? And it actually just says write an equation to represent the model below. So we've got this piece, we've got 2x, and then we've got this piece here. There's 7 negatives, so we can write that as -7 or -7, and then that's going to be equal to kind of the other side of the balance here. In this case is all of this, so we have -17. I'm going to go ahead. Alright, I'm gonna redraw this a little bit. I'm gonna play with this a little bit because I do want to solve this thing as well. So let's just get rid of our drawing here if we can. Maybe not. Okay, so I'm going to redraw our x's like this, and actually I'll draw them green because your book uses green rectangles for our x's. There's our x, and then if we had -7, your book would just show those as like 7 blanks. 3, 4, 5, 6, 7. That's equal to -17, so we're going to draw into 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, -17. Okay, so there it is again, right? Same equation, 2x minus 7 equals -17. Now the way to solve this would be use zero pairs to cancel these guys out. So we're going to add in 7 zero pairs on either side, and that's going to effectively cancel these guys out. So we're getting rid of that. 1, 2. Actually, not. Sorry. Let me just do this over here because I'm kind of sketching this a certain way to help us out here. Just a sec, you guys. Okay. 1, 2, 3, 4, 5, 6, 7. Okay, so we added 7 zero pairs on both sides. So that would look like this in our equation. We're going to add 7 here, we're going to add 7 here. So this cancels. We get 2x on that side, and we get -10 on this side. Alright, that's the step we've done with our equation. So we still have our x's, and actually the 2 x's are by themselves on the left, and that's now equal to -10. 2, 3, 4, 5, 6, 7, 8, 9, 10. And now you'll see why I tried to draw this the way we're drawing it. What we really want is x by itself, and because we've drawn it this way, we can see that each x is equal to -5. That x is equal to -5, and this x is equal to -5. So when we break them up into two groups, we see that x is equal to -5. Our second step mathematically over here would be to divide by 2, and that's how we get that x is equal to -5. Okay, so we did a little more than the question was asking, but we redrew it. We used zero pairs here to cancel, which is the same as adding 7 to both sides. This was a -7, so we added 7 to both sides. We were left with this -10, and that was equal to 2x, and then we broke it up into two groups. We divided by 2. We got that x is equal to -5. Alright, pause and check that out if you're not sure what's happening there. Look at the math, look at the diagrams. Make sure you can figure it all out, you guys, before you move on. If you're ready, here's the next one. -3x. So I'm going to draw those in black. 1, 2, there's my -3x plus 5, so I've got 5 reds. 1, 2, 3, 4, 5 equals -7. So I'm going to draw some hollow guys over here. 3, 4, 5, 6, 7. So there's my -3x plus 5, yeah, equals -7. Okay, and then solve. So the way to solve this using the diagram is to first get these x's by themselves, these guys. So two ways to think about it. I'm going to create zero pairs, or I'm going to add in -5 on that side. right? It's going to cancel all this out. So I'll have to add negative 5 on this side. 1, 2, 3, 4, 5. And now we see, again, I drew this strategically, that we have 3 x's and we have negative 12. So each x is equal to negative 4. Alright? If the diagram's not working for you, here it is algebraically. We had 3x plus 5 equals negative 7. And I'd like you to write both, show both, and try to get comfortable using both. The first step was to get this x term, this negative 3x by itself. So my first step was to get rid of the 5. So I took away 5, or I added negatives to create 0 pairs. I got 0 on this side. I'm adding a negative 5, so I get negative 12 here. Starting at negative 7, I'm taking away 5, I'm moving backwards to negative 12. However you want to think about it, that each of your math is important. So we had 3x is equal to negative 12. And then, oh, just a sec here now. Now that we're doing this, I see a mistake actually. We're dividing by negative 3, so x in this case should actually be equal to positive 4. And I lost track of the fact that's what x is equal to. We see it algebraically. On the left, I lost track of the fact that these are actually negatives. These are hollows. So what we had, in fact, was that negative x is equal to negative 4. And you'll see, if negative x is negative 4, then positive x is positive 4. Right? And we can flip that, or we can multiply both sides by negative 1, but x is equal to 4, negative x is equal to negative 4. Your book is always going to give you an answer in terms of positive x, so make sure you're thinking of that. I apologize, I totally missed this in the first time through because I was messing around with my drawings in here, but these were negative x's on this left-hand side. Okay. Check that out. Make sure you figured out the two, right? The diagram, the model, and the algebra before you move on. Last one here gets a little tricky in the sense we're working with a bit of an interesting word problem. We're talking about these two animals. We've got our cow sleeping 7 hours a day. And then it says this amount of sleep is 1 hour less than twice the amount an elephant sleeps a day. How long does an elephant sleep? That's what we're looking for. And if we read back, nowhere does it tell us how much the elephant sleeps. The question tells us a few things. It tells us the cow's sleep equals 7 hours a day. It also tells us this amount. So we're going to make another statement actually about the cow sleep, and I'm trying to translate the written into some math. So it says this amount. So I'm going to write that again. Cow sleep. This amount of sleep it's equal to 1 hour less than twice an elephant sleeps. And we haven't actually defined the elephant sleep yet, but we see in the question that we don't know it. So elephant sleep, we'll just say equals E, right? We could call it X, could call it whatever we want. It's equal to E. Now in that second sentence, this amount is 1 hour less than twice. So it equals twice E minus 1. 1 hour less than twice. So now we know two things about the cow. We know that the cow sleeps 7 hours a day. And then we know that this amount is 1 hour less than twice an elephant sleeps. So we know this about the cow sleep, and we know this about the cow sleep. What we're going to do is we're going to take those two things and make them equal. 7 hours a day equals 2 times the elephant sleep minus 1. So there's our equation. And there's a lot of thinking that goes into getting there. Make sure you can follow that. Make sure you understand that. But the question gave us two pieces of information about cow sleep, and what we did is we made them equal to each other. So the 7 hours a day is equal to the 2e minus 1. Now it says model using algebra tiles. So I would draw that like, let me get my positives out. I would draw that 7, 2, 3, 4, 5, 6, 7 is equal to 2e. I'm going to use some positive e tiles here, 2e minus 1, and I'd use my black because those are hollow. These should actually be filled in reds, right, because those are positives. And then what I would want to do is I would want to add a red over here, make a 0 pair, and get rid of that guy. So I'd add a red on this side as well. And now we see that we have each E being equal to 4 hours, or 4 reds, right? Algebraically, it would look like this. 7 equals 2E minus 1. We added 1 to both sides, making this 0. So we had the 2E piece by itself, making the left-hand side 8. 8 is now equal to 2E, and we divide by 2 to get that 4 equals E. Alright, you could have written it like this, 2E minus 1 equals 7. You could have solved like that. I just flipped it. We just did it the other way around. You could now take our answer, 4 equals E, and you could put that back into our equation, right? 2 times 4 minus 1 is 8 minus 1 is equal to 7. So it all checks, it all works, right? Again, make sure you can follow the diagram, the algebra. Solve by applying opposite operations. Opposite operations work like this in these two-step guys. One, we get the x term by itself, or the unknown term by itself, like the e term right here. We're trying to get 2e all by itself. Then we get the x by itself, right? So then we did this division step here to get the e by itself. And remember, this is an opposite operation. We had 2 times e, so we divided that by 2, right? We had 2 times e, and we divide by 2. So those are the opposite operations we're using. That was what we learned in the first section, and now we're kind of moving on to use those opposite operations in two-step equations. I'm going to suggest you pause here and try the last two, make sure you can do them, and then I'll just show you the solutions in a moment, okay? Check them out. Okay, here's the solutions on the bottom if you're just checking. If you're trying to follow steps, we first get the x term by itself. So in this case, we're taking away 7 on both sides. We get that the negative 3x is equal to 12. And then because it's negative 3 times x, we're dividing by negative 3 on both sides. We get that x is equal to negative 4. So I'll just write that in. We did 12 divided by negative 3. On the right, we wanted to get the 4r term by itself, so we added the 6 to make 0. This stuff cancels. You can show that if you want. That's gone. This was gone over here. So we had that 20 is equal to, sorry guys. We get that 20 is equal to 4r, and because that's 4 times r, we're going to divide by 4 to undo that multiplication. We could show that these are canceling, right? We're left with r. We could show over here that this is canceling. And we're left with r is equal to 5. Alright, so again, make sure you understand the algebra before you go on and try the assignment. Once you're done, the assignment's on the blog, you guys. Thanks, good luck.